Hello everybody, I am Dr. Ashwini Kulkarni, Assistant Professor and Head Department of Applied Mathematics. In the Department of Maths, total courses offered exclusively for BTech first year are Mathematics 1, Mathematics 2, both comprises of 100 marks. Today, I am going to focus on BTech first year, that is Mathematics 1 of BTech first year paper, whose subject code is BES11 with total credits of 4, 3 theory lectures and 1 tutorial based on these theory lectures in every week. It has a university question paper of 3 hours. Now, regarding examination skill, out of 100 marks allotted to M1, 70 marks are for university question paper and 30 marks are for internal evaluation based on CAT 1, CAT 2 sessional exams. Now, let us discuss objectives of this course. Why to study? Main objective of course M1 is to make students aware with the techniques with which they can understand advanced level mathematics, and secondly, with these advanced skills of mathematics, students will be able to understand engineering problems effectively. Now we will discuss in short the content, that is syllabus of M1. It is unitized syllabus distributed in 5 units. Unit 1 is titled as differential calculus based on the concept of differentiation. First is successive differentiation process, means we go with recurring derivatives of the given function, where in the process we use a Leibniz rule. Then using Taylor's and Maclaurin series, we can expand the function of one variable in series form. Then we study maxima and minima for function of one variable. Students can also evaluate complicated limits with a simple technique using L'Hospital's rule. The second unit, namely multivariable calculus. Calculus means differentiation. Here we will considering throughout the function of at least 2 or more than 2 variables, that is f of xy. Since function of 2 variables, while differentiating with respect to one variable, we keep other variable constant, that is, we study partial differentiation process. Then how to find total derivative of the function of more than one variable. Here we need to use the chain rule for knowing total derivative. Again, we focus on finding maxima and minima for function of 2 variables, that is f of xy, where we apply special Lagrange's method of undetermined multiplier. Both unit 1 and 2 of M1 is completely based on differentiation process. Now the third unit is of matrices, in which student needs to find inverse of matrix by partitioning method. Consistency of system of linear equations can be checked by finding ranks of the matrix. Then the types of matrices such as symmetric, skew symmetric, and orthogonal matrix, where A inverse is A transpose is the property to be discussed. Next, fourth and fifth, both units are about differential equation. In fourth unit, differential equations which are of first order and first degree, categorized as linear, Bernoulli's, exact type, to be studied by the students. Also, some differential equations of first order and higher degree to be discussed here. Many problems of electrical circuits, that is RL series and RC series circuits, can be solved using these concepts of differential equation. Now, the last unit, that is fifth unit, is titled as higher order ordinary differential equations with constant coefficients. As an example, d square y by dx square plus 4 dy by dx plus y is equal to sine 2x can be solved with a general method and also with one specific method known as method of variation of parameter. Some special type of differential equations, namely Cauchy's and Legendre's, also simultaneous differential equations, are to be studied with their applications to LCR series circuits. Is the discussion about the unitized syllabus of Applied Maths 1. Then we come towards the utility of the subject M1. Why to study it? What is the use to study M1? Means the applications. In first two units, we discuss concept of ordinary and partial derivatives, which are commonly used for finding rate of change of quantity, finding the approximate value, finding the equation of tangent and normal to the curve, finding maxima and minima and point of inflation, determining increasing and decreasing functions. Again, the third unit is of matrices. Most application of matrices is in finding in optics to account for reflection and for refraction, in electrical circuits and also in quantum mechanics, and for resistor conversion of electrical circuits, we can use matrices. Matrices are also used to solve AC network equations in electrical circuits. In fourth and fifth units are of differential equations. There are tremendous applications of differential equations. To name the few, to calculate moment of flow of electricity, motion of an object like pendulum, to explain thermodynamics concepts. In medical terms, also differential equation is used to check the growth of disease in graphical representations. Now we will see some applications of spatial terms studied in M1, namely Euler's theorem. Euler's theorem, studied in partial differentiation, is applied in thermodynamics because thermodynamics functions are homogeneous functions. Then it is also used in Hamiltonian equations. Again, the spatial Legendre's equations we have studied in fifth unit, where Legendre's equations are used for determination of wave function of electrons in the orbits of an atom. Also in the determination of potential function in the spherical symmetric geometry. So such a tremendous applications are there of partial and ordinary differential equations. This is the utility of subject applied mathematics. Thank you once again.